Hayokor.
Oh, well, hello, Patriots. I didn't know you were there. You're a little bit early, but that's all right because this gives me a good opportunity to show you about what we're going to talk about today, and that is the relationship between the standing wave ratio on your antenna and radio combination. The standing wave ratio sometimes confuses people, but it's a very critical element to having a radio antenna combination that will maximize your radio's potential and keep from damaging your radio. So a little bit of knowledge of SWR is necessary for anybody that messes with radios in any capacity. So since we're here, you ever been watering your garden? You got all kinds of water, everything's flowing like it should. Well, if your radio and your antenna have the proper SWR, then the signal will get out without any restriction. So if you can envision this water as your radio signal trying to leave your antenna, if you don't have the proper ratio on your standing wave ratio, in effect, in a layman's way of explaining it, it's almost as if you have a kink in your hose. And your radio signal being represented by the water, it kind of gives you that. If you have a standing wave ratio that is improper, and we'll talk about a little bit of the theory and the numbers that you're looking for and how to check that. But just to visualize it, I wanted to show you that if your standing wave is good, you're going to have unrestricted flow. Because we know we got 40, 50 pounds of water pressure coming down this hose, and it's making its way out the end with no restrictions. But if you have a bad standing wave ratio, not only is it going to reduce the amount of signal that gets out of your antenna, but the back pressure on this side of your antenna, the radio transmitter side, that energy is reflected back into your radio and can overheat your components and potentially cause damage to your radio. So we're going to cut from here and move up to the bench. I got some SWR meters, I got a radio, and I'm going to give you a quick and dirty lesson on SWR. We're not going to turn you into electrical engineers or nothing. It's just going to be real rudimentary, and we just like I said, we always want to get you thinking about a topic, and hopefully we can generate some curiosity on your part that you'll pursue it in more depth and come to a greater understanding. But this is definitely a basic skill that I think any man, regardless if he's a prepper or not, should have some understanding of, because this is critical to making your radio talk and receive to its fullest potential. So with that, I'll see you up at the bench. Welcome back, Patriots. I hope you enjoyed our little introduction there. We're just trying to have a little fun. We always like to try to get a smile or a laugh if we can. Some of this stuff is pretty serious topics, but there's nothing wrong with laughing and having a little fun. Kind of did a little Benny Hill, if you guys remember that guy from way back. That was one of his classic gags. But anyway, it's a very good representation. As the water flowing freely from the hose, that's representative of your radio transmit signal radiating smoothly from your radio through your antenna without any kinks or choke points. It's a good way to visualize that. That's why I went ahead and introduced it that way, because it's a good visual. When you push transmit on your radios, it doesn't matter what kind, what band that you're running on. Every frequency, every band, every group of channels, the antenna has to be cut to the specific length of the frequencies you're trying to transmit on. And in doing that, when they're designing antennas, when you're building antennas at home, you can follow the math, do all the formulas, which I suggest you familiarize yourself with those. And still, when you get the finished product, you may need to make some adjustments. If many of you are familiar with the CB antennas, used to be you would loosen a little Allen screw and just raise your antenna whip up or down a little bit. If you've ever checked SWR on those, on a homemade wire antenna, you'll probably just maybe cut a half an inch off or inch of all the elements and then take another reading. But what we're going to do is going to show you basically how SWR meter works. There's all kinds of different models out there. It doesn't matter which one you use. Some are better than others. This is one I got here. It's not top of the line by any means, but it's a pretty common one for the 2 meter UHF, VHF, frequency bands. So what you're looking for is as close to 1.0 as possible. That means there's no impedance, there's nothing hindering your transmitting power coming from your radio, getting through your antenna and radiating into the air. That's what you're really looking for with a standing wave ratio, is how much of your transmit power is actually being put out into the air. If you have a very high number, let's say you key it up and your meter says, well, you got a 4.56 or whatever, that's way too high. Now, bear in mind, handheld radios being what they are, when they make the antennas for these, there's lots of compromises in the units themselves, just in an effort to make them practical and portable. The best antenna match you could have is an antenna as long as the wavelength that you're trying to transmit on, and that's just absolutely impractical. Even on the higher frequencies, you still are going to have a antenna that is a half of that wave or a quarter of that wave. And the radio or the antenna engineers, they design these antennas with those compromises, and part of that compromise is your body on a handheld makes up the ground portion of your antenna. So having said that, it's my understanding that when they design radios, handheld radios, they design them to operate best when you're talking into them, because that's how they're designed to be used. Now, obviously they got speaker mics and so forth and so on, but the whole concept of a handheld portable radio forces the engineers to make compromises to make them handheld and portable. So bear that in mind. What we're going to do, this is a stock antenna that came with my AR-152. They do a pretty good job out in the field. They're not the best antenna, probably not the worst antenna, but we're going to go ahead and check the SWR. I've got the proper adapters inserted into my SWR meter, got my antenna connected. You always want to make sure you got the antenna connected to the antenna side of it and the transmitter attached to the transmitter side of it. So be familiar with your meter. Pay attention to detail. It's little things that keep from creating big problems. The other thing I want to mention at this point is whenever you're messing with your radio, and it doesn't matter what kind it is, never key up your mic, never push your push to talk button if you do not have an antenna or a dummy load that can handle the wattage that your radio is pushing out. If you key it up without any way for that energy to escape the radio, it's just going to sit there and create heat, and it could cause you problems, could burn out components. That's a possibility. So just try to avoid keying up your radio. You might do it for a second or two and get by with it if you do it handling it by accident, but I try to make it a practice to whenever I'm changing an antenna or putting a meter on or hooking up a coax, or it doesn't matter what I'm doing, I always try to turn my radio off when I make any kind of connection to my antenna. And so try to remember that. It might save you a little money down the road. So this particular SWR meter, it's designed according to the directions that when you key the mic, you try to transmit on your radio, it instructs, in its instructions, it tells me to hold on to the body of the SWR meter. And I'm assuming that that's, because you're actually part of the ground, like we spoke earlier about how they design these antennas. So I will show you the difference that it makes on the meter if you don't do that. So here we have just a stock AR-152 Baofeng, and I've already got the SWR meter connected, I had to use some adapters to make it easily connected. If you're gonna fool with radios, you're gonna need a box full of goodies and adapters. If you're gonna build antennas or connect meters or whatever you're doing, you're gonna need some adapters. You know, don't have a whole big string of adapters. Try to minimize how many adapters you use, whether it be connecting to your meters or connecting to maybe a homemade antenna. Just try to get as few adapters in a chain as possible. But having said all that, let's take a look at the SWR. Now, like I said earlier, if you could envision that water coming out that water hose in the opening sequence, and then when I kinked that hose off, you saw the water go down in drastically the amount of volume and pressure. And that, to me, to my mind, that is a good visual representation of kind of how your standing wave ratio works. So what you want is just open, free, unrestriction, no restrictions to your transmitted signal. You want it to come through your antenna, through your radio, out your antenna, and out into the atmosphere. Hopefully not to be intercepted by some godless communist hordes that are roaming around your AO. Hopefully you get it to the people you need to get it to, and we accomplish our mission. But let's go ahead and key this baby up and see what we get for numbers, just to show you. And like I said, if you're a beginner in this, don't let this stuff intimidate you, because, you know, I said in an earlier video, when I joined the Marine Corps, I had to learn to speak Marine, man. I mean, I didn't know the bathroom was the head. I didn't know the drinking fountain was the scuttlebutt. I didn't know the floor was the deck, and so on and so on and so on. So you're going to have to learn some terminology, but don't let that intimidate you. There's plenty of people out there to help you. There's lots of good videos on YouTube besides mine that will go in greater depth. I am not I don't hold a very high ham license at all. I'm not an engineer of any kind. But if you're going to operate radios, you need to be able to understand a little bit of the physics behind it, so you can get the most out of your radio and maybe troubleshoot problems as you encounter them. So, like I said, this is all about knowing what standing wave ratio is, knowing what it can do to your radio, knowing how it can hinder your transmission, and knowing how to check what to look for, and then take appropriate action. If your standing wave ratio is too high, you're going to have to make some kind of an adjustment. Now, they also, I've read articles, many different articles, and there's some conflicting information out there that says, well, a handheld is designed to handle antenna with a 6 SWR. Maybe it is, maybe it ain't. I don't know. But if 1.0 is the target, the closer you can get to that, your radio is probably going to operate better. So as a rule of thumb, lower is better. So here we go. Let's go ahead and get a reading off this stock AR-152 antenna. So we got it turned on, and per to the directions, I'm hoping the camera can see our numbers. I'm holding on to it as instructed, and let's key it up and see what we get. Looks like 1.01. That's an outstanding SWR. I always get that when I check this antenna. I'm not going to tell you that this little meter is 100% accurate, but I will say this: it's measuring in some capacity. It may be a plus or minus tolerance in it, but let's see what kind of number we get if I don't hold the body of the meter. Now, we're going to key it up again. I'm just going to hold the radio up and see what happens. Now we have, well, still have a 1.0. Let me see here. Okay. Now let's go to hold the radiating element and see what the difference is. There you have a 7.77. So as you can see, you know, because of the design of this meter, it's designed to measure SWR on handhelds. You need to, you know, be grasping the shell of this particular SWR meter. We did get the same without doing that, but I have also gotten different readings. But follow the directions that come with your meter, and, you know, like I said, here we got should be a 1.01, which is a great SWR. It is. And then once again, if I get a hold of the antenna itself and make myself part of the radiating element, you'll see it's 7.63 that particular time. So you're shooting for 1, maybe up to a 2, you know, but the closer you can get your antenna to 1, the better off you are. Now, having said that, on these little whip antennas that come, these rubber ducky antennas you get with a lot of them, there's probably not a whole big lot you're going to do about it. You know, if that's what ships with your radio, it's probably designed to work with that radio, but probably not the most efficient. In fact, they hardly ever are. You can always get better performance with a better antenna. And like I said, compromisers are built into the antenna simply to make it practical to be a portable handheld unit, and not a base station with a much larger antenna. Here's one of the Abri tactical, you know, the tape antennas. You get them all different lengths. This one's got a gooseneck. I think they have their place. They're not the best antenna. They're not the worst. Depending on what your situation is, you probably need to just do some practicing and patrol around and use your radios and find out what works for you and what doesn't. On one of the earlier videos we did on the AR-152, just as an example, I had the stock antenna on it, and I tuned up our local FM radio channel. It's about 45 miles away from here. And with this antenna, all I got was static. But when I replaced it with this antenna, the signal came in loud and clear. Now, I don't know if that would be, how much difference that would make if you were transmitting, if we put a power meter and a field strength meter and all these things on it to measure our transmission. But as far as reception went, it was obvious that this antenna will allow this radio to pick up weaker signals than this antenna does. It was night and day. So if you haven't seen that video, you can go back and look. We've done a couple videos on, you know, the radio and the little solar charge panels and things like that. Let's go ahead and check the SWR on this big one. Like I said, this is one of the Abri military tape antennas. They come in many different lengths, and you know, whatever you need, you should be able to find something that'll work for you. And this does have the gooseneck. I do like the gooseneck, because if it's on your antenna and you drop it or run into something, you know, the gooseneck it's got give in it and will protect the connection on your radio. Those SMAW male connections are kind of an Achilles heel of the Baofeng series of radios. I think everybody that messes with them wish they would go to just a stock BNC, but that's another video. Let's go ahead and check, see what we get on this Abri antenna for an SWR. So we got it powered up. I'm going to hold it like I did, like its instructions say to do. See what this antenna gives us. And I'm hoping the camera picks this up. This is a 2.20. So, you know, this one was 1.01. I don't know if that's 100% accurate or not, but I'll take it. This antenna, which is designed for these kind of radios, 2.02. That's probably acceptable for a handheld. Let's go ahead and get a hold of that radiating element, and just to show you what the difference is. We're not holding the body of the meter as the instructions tell you to do. So we're going to get a hold of the antenna just so you see that it is actually measuring, and we can see the difference in the numbers based on, you know, if we get a hold of the radiating element or follow the directions and work it as it's designed. So see what we get. 2.32. A little bit of difference, not a huge amount, but still different. Let's try this. 2.0. And with the Abri, let's go ahead and fold it. See what happens. Usually it's typically, everybody says, you know, don't try to transmit them with them folded, because you'll have limited range. Maybe sometimes you want limited range, so situation you're in, you may want to run it folded, but nevertheless, let's see what we get. It's 2.76. So, you know, there's differences depending on your antenna, you know, and that's what you're looking for is what each antenna will actually do on your radio. Let's go ahead and key it up with this properly. We'll hold the shell of the meter and see what it looks like when it's horizontal. See if it makes a difference. I don't know if the camera's got that. 2.73. So just about any way you want to hold this antenna, it's still going to be a little bit high, but probably functional. Probably not going to hurt your radio. Probably going to do an adequate job. But with that, I hope this gives you an understanding of what standing wave ratio is really talking about. It's merely how much of the energy from your transmitter is actually getting out of your antenna. And you know, if you have a high SWR on any antenna, in my mind, a good visualization of that is like the water hose with the water coming out freely, or if you kink the water hose, you can see how the flow is diminished. In my mind, that's the way I visualize SWR. I'm sure it's probably going to make some engineer freak out, but you know, I apologize. As long as we understand the principle, that's the key. You can visualize it any way you want to. But having said that, folks, if you don't have an SWR meter in your kit and you have radios, you need to get you an SWR meter. If you don't have radios, you need to get some radios, because you got to be able to move, shoot, and communicate. And sometimes the communicating is the most important, if not always. So having said that, we like to just tell you that, you know, the maximum effective range of an excuse is 0 meters. Don't be that guy that shows up with the Motorola Talkabout to the firefight, or to the revolution, or whatever you want to call it. Comes down here to zombie apocalypse, and he shows up with a Motorola Talkabout and don't even know how to get through his channels, and he wants to be he wants to be your RTO. I mean, you need, you know, don't be that guy, dude. Learn your radio, learn some radio theory, build you some antennas, get your hands wet, get your feet wet, get your hands dirty, get off the couch, get out there and do something. Talk is cheap, bro. Talk is cheap. Get out there and hustle a little bit. You'll be glad that you did. But having said that, this old Core 1057 saying, hey man, keep the faith, Semper Fi, and always, always demand liberty.